Okay, ladies and gentlemen, today's lesson is going to be comparing and scaling 1.2. We're going to also make sure we want to put down that we have homework 1.2 today. We'll get some help with that today, hopefully if we've got time. And our goal is that I can apply ratios, comma, fractions and percentages to real life. Okay, we're continuing our understanding of what it means to have a ratio. Take that ratio, make it into a fraction, take that fraction and make it into a percent, and basically having a whole bunch of different toolboxes, a whole bunch of tools in our toolbox in which to describe numbers and how they relate. Let's go ahead and get started. So here's a little warm-up, a little kind of introduction to the kind of problems we're going to be working on today. Mr. Briggs spends 6 hours sleeping, 4 hours teaching, 2 hours grading, 3 hours planning, 2 hours eating, 2 hours relaxing, 2 hours watching TV, and 3 hours blasting space goblins. Basically, I play a lot of Halo. What percent of his time is spent sleeping? Well, how do I solve that problem, guys? Well, first, what number represents the time I spend sleeping? Okay, that would be 6 hours. So 6 is going to be the first number I have to consider. Now, am I talking the percentage of the hours in a day? Or am I talking all the other numbers? Well, how many hours are there in a whole day? What is my total? Because I'm going to take that 6 and divide it by the total. And how many total hours are there in the day? 24. And when we do 6 divided by 24, what we end up getting is 0.25, which then becomes 25%. So I spend about a quarter of my day just sleeping. How lazy is that? Oh my gosh, Mr. Briggs, you are so lazy. You spend a quarter of your day just sleeping, right? Well, what is the ratio here of grading to Halo? Well, what's the number for grading? The number for grading is 2 hours. So 2 is going to be my first number. And I put in my little colon there. What is the amount of time I spend grading? 3. So 2 to 3 would be my number. So if that's the case, 2 to 3, that means every 2 hours I spend grading, I spend 3 hours at home shooting space goblins. Do I actually spend that much time playing video games? Probably not. This is just an example. Although I usually am lucky to get this much sleep. So that kind of leads into our kinds of problems that we're going to have on our classwork. Our classwork is all about comparing ratios and fractions and using them to solve some really basic problems. The first thing I want to look about is we want to take a look at this very top part. And we have two things here. We have a ratio and we have a fraction. A ratio is a part to, this is the important part that we want to put in there, a part to part relationship. If I have a slice of pizza here, one part goes to you, one part goes to your friend. So a 1-to-1 ratio is a part-to-part relationship. Okay? We don't talk about what everybody has. We just talk about what do you have, what does the other guy have. Now a fraction is a part-to-whole. How many total slices are there? Okay? So, if there are 2 slices of this pizza and you get one of them, there were 2 total. Okay? But your slice was just 1. And that's what makes a fraction different from a ratio. Is a ratio does not add up all your parts together. Okay? A fraction does. And in order to go from a ratio, something we have in the real life, like I've got 3 marbles, Jack has 8 marbles, Billy has 7 marbles, right? That's what we have in real life. A fraction is when you have to look at everybody's marbles together. How much do you have compared to the total? And that's where we get 50%. That's where we get a decimal. That's where we get a lot of the stuff we're going to be using. And in a lot of these problems, we need to decide, do we need a fraction or do we need a ratio? Which tool is best? Okay, so let's take a look at our first sort of problem here. Students at Nielsen Middle School are asked if they prefer watching TV or listening to the radio. Of 150 students, 100 prefer television, 100 prefer radio. Well, the first thing I'm going to do is I'm going to analyze these 3 numbers they give me. That 150, that 100, and that 50. Well, the 150, is that a part or is that a whole? If you answered correctly, that is the whole, right? The total number of students. Okay? These 2 sections that I've circled are parts. Okay? 100 like television, 100 like 50 like radio. Together there are 150. So, how would you compare student preferences for radio and television? What different ways can we compare them? Think about them for a second. Okay? Pause the video, write down some different ways we could compare them, and then restart this when you're ready to talk about it. Okay. Well, we can talk about a difference, how many more like television than like radio. We could talk about the percent who like radio or TV. We can talk about the ratio, this many students of the ratio of TV to radio. For every this many students who like TV, this many like radio. We could talk about the fraction of students who like TV or like radio. There are lots of different ways we could describe this. But now we need to actually use them for Part B. Part B. We need to decide if each statement accurately reports. Basically, is it true? The results of the Nielsen Middle School survey. And the survey is this stuff that was up here. Okay? At Nielsen Middle School, 1/3 of the students prefer radio to television. Well, first, 1/3. What is that? Is that a ratio? Is that a fraction? Is that a decimal? Is that a percent? It's a fraction. So if it's a fraction, we need to have the part, we need to have the whole, right? Because those are our rules for fractions up here. So, what part are we talking about? The students who prefer radio. Well, how many students prefer radio? 50 prefer radio. Out of how many students total? 150. So there's my fraction, 50 out of 150. Can I make that smaller? Can I make that, reduce that to a size where it will be, where I can compare it to 1/3? Well, sure. What goes into 50 and 150? 50. So if I divide the top by 50 and I divide the bottom by 50, 50 divided by 50 is 1, and 150 divided by 50. Take a second if you need to use a calculator or just think about it. You could count on your fingers. 50, 100, 150. I get 3. So yeah, 1/3 of the students prefer radio. So this question right here is a big old yes, a true answer. Number 2, students who prefer television to radio by a ratio of 2 to 1. Okay, ratio. Ratio. Okay, ratio. Well, a ratio, they want a ratio. So first we need to find students who prefer television. What's that number? Well, let's look at our facts here. Well, 100 students prefer television. And the number of students who prefer radio is 50. So I have 100 to 50. Okay? For every 100 kids that like television, 50 like radio. Can I make that smaller? Well, what goes into 100? What goes into 50? I bet you know already. I bet you know. If we divide both by 50, the biggest thing I can think of that goes into 50 and 100. How many 50s fit into 100? 2. How many 50s fit into 50? 1. 2 to 1. So is that true? For every 2 students who like television, does 1 student like radio? That's a big old yes / true. Okay? We took the numbers we had, we made them smaller just the way we would in a fraction, and we got 2 to 1. Okay, and then the last question. The ratio of students who prefer radio to television is 1 to 2. Well, think about this. Didn't we just do this? Let's try this again. How many like radio? Well, 50 like radio. How many like television? 100. Do you see a resemblance to what we had up here? If I reduce these both down, divide by 50, I get 2, I'm sorry, not 2 to 1, 1 to 2. For every 1 person that likes radio, 2 people like TV. So that's a big old true / yes. So all of these so far are true. This seems very unlikely, Mr. Briggs. Let's move on to the next problem, number 4. Okay, number 4 down here. The number of students who prefer television is 50 more than the students who prefer radio. Okay, well, we need to do the number of students who prefer television. Well, how many students preferred television? 150. Nope. That's the whole number of students. 100 students liked television. Only 50 liked radio. If I do 100 minus 50, that means 50 more kids like TV. So is that statement true? That's a big old yes. Oh my gosh, Mr. Briggs. This is just too crazy. So far, every one of these is true. Okay. The number of students who prefer television is 2 times, double the number who like radio. Oh my gosh. Well, let's think about this. The students who like television is 100. Okay. I'm going to make myself a little chart here. TV and the students who like radio was 50, is the number of students who like TV twice that of radio? To get from 50 to 100, what did I have to multiply by? 2. So is this true? Yes, it's true. Oh my gosh, Mr. Briggs, you're just like messing with us. This is one big problem. Okay, 50% of the students prefer radio to television. Well, I know that 50 students like radio. Does that mean 50% of the students prefer radio to TV? Well, how do I find a percent? I know that 50 students prefer radio, and I need to divide that by the total, which is 150. So 50 divided by 150. Go ahead and put that into your calculator. 50 divided by 150. If you do that, you get about 33.3%. Not at all close. Okay? If that were the case, half of the students would like radio, half of the students like TV. So for the very last problem, we get a big no. Now, take a look at the statements in 4 and 5. Okay? 4 talks about the number of students who prefer television. 50 more kids like television than like radio. Number 5 tells us that twice as many kids like TV than like radio. Which of these tells us more information? Which one is more accurate? Well, if all I tell you is that 50 more kids like television, does that tell me anything about the whole? Does that compare anything? I could have, sure, we know because we've seen the data that 100 kids like TV, 50 kids like radio, but it could have just as easily been like 1,050,000 kids like television and 1,000,000 kids like radio. We don't know if that 50 is a big part of the whole or a small part of the whole. But if I tell you that twice as many kids like television, well, that's a big number. Let's say 3 kids like radio. I know 6 kids like TV. Let's say 10 kids like radio. I know 20 kids like TV. So, which is the better statement, 4 or 5? I would tend to lean to 5. Because 5 tells us a 1 tells us a 2 to 1 ratio. That double the number of kids like television. Okay? 2 to 1. By saying double of the kids prefer television, we are saying that twice as many kids like it. They basically give us a ratio. Telling us 50 more kids doesn't tell us that. It only tells us that this many more kids like it than that. Doesn't give us enough info. So now, ladies and gentlemen, take a look at D. Okay? Consider only the ones that are true. And answer these 2 questions before you start your homework. Show them to Mr. Briggs so that he has a pretty good idea that you get this. Discuss them with your neighbors, and then we'll start our homework. Number 1, which statement would best convince merchants to place ads on radio? Why? Which one of these things would you use to say, hey guys, look how awesome radio is? And remember, it has to be a true statement. You can't lie to them. But which one of these sounds the best, right? If you wanted to sell radio, if you work for the radio company, you want to find the one that sounds the best. And which one would you use? And number 2, which statement would tell you that television is the way to go? Please find the correct one, and tell me why you think it's the correct one, and then show it to me before you start working on your homework. Go ahead and discuss it with your neighbors. But before we really go on and do that, before we go on and get started, I want to discuss really quickly how we're going to do the homework. Okay, on the homework, we have a student. We got a guy named Carlos, this kid named Carlos. And Carlos took an idea. Okay, how many on the weekend, how much time did he spend, okay, doing different activities? He spent 18 hours sleeping, 2.5 hours eating. He spent 8 hours with recreation, basically playing, right? Okay. And then he spent 2 hours talking on the phone, 6 hours watching TV. He had to do chores for 2 hours, and then he did other stuff, just other stuff for 9.5. It doesn't fit into anything. Who knows? So we want to know, for example, how could you compare the stuff he does? Could you use fractions? Could you use percents? Could you use ratios? Okay? What would be the best way? And then for number 2, you need to decide, are any of these things true? Okay? Did he spend 1/6 of his time watching TV? Did he spend, is the ratio of hours spent watching TV and the hours watching television and doing homework 3 to 1? Decide which of these are true. But there's one thing you're going to need to do first before you do any of these. Take all of these numbers, 18, 2.5, 8, 2, 6, 2, and 9.5, add and give me the total hours. Okay, the total hours on the weekend will help you decide what will be in the fraction, what will be in the percentage, what will be in most of these problems. Okay, ladies and gentlemen, go ahead, fill out problem D with your best answers, and then start your homework. Have fun.